now if we go to another question, so it came in the year 2020 and the question number here is 15. So the question states that at a given pressure, a substance is heated from 2000 Kelvin to 2600 Kelvin. If the entropy of the substance is 60 joule per Kelvin per mole and is assumed to be constant over the given temperature range, then the change in chemical potential of the substance is. So to solve this question, you need to first know that what is a chemical potential. Chemical potential can be also defined as the Gibbs free energy per unit moles. Okay, so the change in Gibbs free energy per unit change in the mole of the substrate or the substance. Okay, so that is also called as the chemical potential, that is denoted by mu. Okay, and in this mu is also sometimes denoted as G bar. G bar means G is the Gibbs free energy and that is divided by N. N is the number of moles. Okay, so this mu value is dependent on Gibbs free energy that we can come that we actually know from this definition. So and the Gibbs free energy is dependent on enthalpy, entropy, and the temperature, as you have seen, for that is del G equals to del H minus T delta S. Okay. So in other words, the chemical potential mu I is a measure of how much the free energy of a system changes if you add or remove a number dni particles of the particle species I while keeping the number of other particles like and the temperature and pressure constant. Means if you add a certain number of moles to a substance, okay, so then what is the change in the free energy by doing so, or if you remove a dn number of particles from that substance, then what is the change in the free energy. So that is given by this chemical potential, keeping the temperature and pressure constant. Okay, so that can be also defined in terms of entropy and temperature. So the chemical potential is equals to, if you this is a derivation, you need to write the formula of del G, then you need to break all the terms of enthalpy and entropy, and you need to take del in left hand side and right hand side, and you will be coming across this formula, that is minus delta S multiplied by delta T is equals to your chemical potential. So the change in temperature multiplied by your change in entropy, and there is a negative sign because as I said that del G equals to del H minus T del S. Okay, so from there this negative sign is coming and this chemical potential is given by this formula. To solve this question you need to know that this formula. Okay, then only you will be able to solve this question. So now it is easy. So you know the chemical potential is minus delta S multiplied by the change in the temperature. So in your question, if you see that there are two temperatures already given. So the initial temperature is given as 2000 Kelvin and the final temperature is 2600 Kelvin. So delta T you can easily calculate from these temperatures. The final temperature minus the initial temperature, and this they have said that the entropy is constant and the entropy value is given as 60 joule per kelvin per mole. So just you need to substitute these values in this formula, that is minus delta S multiplied by the change in temperature. So delta S value is given as minus 60, so there is a negative sign, so minus 60 multiplied by 2600 minus 2000. So you will come across the value will be minus 36,000 joule per mole. Again, if you see here, they have said you that they want the answer in kilojoule per mole. So you, after finding the answer that is minus 36,000 joule per mole, you need to convert it into kilojoule per mole, that is minus 36 kilojoule per mole. Okay. So for your reference, what I have done is that means you can look into these two courses for getting some concepts in the thermodynamics part. So they are very good courses in NPTEL, and since it is a 1 hour class and I need to cover means I am mostly solving questions and not going into the details of the derivations. So if some of you are interested, you can look into these courses in NPTEL. Okay, so for your reference, what I have done is that means you can look into these two courses for getting some concepts in the thermodynamics part. So they are very good courses in NPTEL, and since it is a 1 hour class and I need to cover means I am mostly solving questions and not going into the details of the derivations. So if some of you are interested, you can look into these courses in NPTEL. Okay.